Welcome. This lesson deals with the expansion of a product of two algebraic linear expressions. This topic is covered in Secondary 2. I will show you how to do the expansion using the multiplication frame method and the distributive law. This lesson is the third of a suite of video lessons on expansion and factorization of algebraic expressions. You will be asked to participate in this lesson. When you are asked to do so, pause the video to work on the task. Let's take a look at the lesson objective now. In this lesson, you will learn to expand a product of two algebraic linear expressions using the multiplication frame method and recognize the relationship among the terms in the expanded form. Let us now begin by recalling what an algebraic linear expression is. It is an algebraic expression where the highest power of the variable is 1. How does such an algebraic expression look like? Let us consider algebraic linear expressions in the variable x. They take the form ax plus b, where a and b are constants. The term with the variable x is ax, and the power of x is 1. Below are some examples of algebraic linear expressions in x. Do you remember how to expand the product of a number and an algebraic linear expression using the multiplication frame method and the distributive law method? Let us begin with the multiplication frame method. Given 2 terms of x plus 3, let us draw out the frame and fill in the number 2 in the first column and x plus 3 in the first row. What do you fill in the blue boxes? 2 times x to give 2x. 2 times plus 3 to give plus 6. So 2 times of x plus 3 is 2x plus 6. How does the distributive law method work? First, distribute 2 to x to get 2x. Next, distribute 2 to 3 to get plus 6. The two methods should produce the same result. When you are asked to expand 2 terms of x plus 3, you need to multiply out the product of 2 and x plus 3 into a sum of 2 terms, 2x and 6. Let us now look at another example. In this example, I'd like you to use the multiplication frame method and the distributive law method to expand the product of x and x plus 3. Pause the video to do it. I give you a minute to complete the working. Alright, let's go over the workings. For the multiplication frame method, did you fill in the factor x in the first column and x plus 3 in the first row? If you did it correctly, you should get x squared and plus 3x in the blue boxes. So, the product of x and x plus 3 is x squared plus 3x. For the distributive law method, did you get this when x is distributed to x and then to 3? Both methods should produce the same answer. You have now recalled how to expand the product of 2 and x plus 3 and the product of x and x plus 3. What if you are now asked to expand the product of x plus 2 and x plus 3? How is this expansion related to the two expansions above? Let us now take a look. I am going to give you some idea of what you are learning in this video. These are the two expansions you recapped earlier. To expand the product of x plus 2 and x plus 3, this is what happens. The expansion involves putting together the two earlier expansions. This means that the product of x plus 2 and x plus 3 is adding up the product of x and x plus 3 and the product of 2 and x plus 3 to give x squared plus 3x plus 2x plus 6, which are the four terms in the blue boxes. Simplifying them, you get x squared plus 5x plus 6. The result is a quadratic expression in x. What is a quadratic expression? It is an algebraic expression where the highest power of the variable is 2. In x squared plus 5x plus 6, which you saw in the previous slide, the two terms containing the variable x are x squared and 5x. The power of x in x squared is 2, and the power of x in 5x is 1. So, the highest power of x is therefore 2. This is why x squared plus 5x plus 6 is a quadratic expression in x. The table shows 6 algebraic expressions. State whether each of them in the table is a quadratic expression in x. If it is not a quadratic expression, give a reason. Pause the video now to do it. I am giving you 1 minute to complete this task. Let's go over the answer. Expression 3 and expression 6 are not quadratic expression in x. The others are. Why is expression 3 not a quadratic expression? The reason is the highest power of x is 1 and not 2. Or you can say that the expression is missing a term in x squared. What about expression 6? The highest power of x is 3 and not 2. Therefore, x cubed minus 3x squared plus 1 is not a quadratic expression. To sum up, a quadratic expression in x has the general form ax squared plus bx plus c, where a, b, and c are constants, and importantly, a is not equals to 0. How are you following the lesson so far? The topic is not difficult, right? In the next part, we are moving on to expand the product of two algebraic linear expressions. I will show you two examples, then followed by practice. Let's continue. Expand the product of b minus 1 and b plus 4 using the multiplication frame method and the distributive law. Let me demonstrate using the multiplication frame method first. We draw a 3 by 3 frame. Where shall I fill in b minus 1? The first column or the first row? Either one is okay. I choose to fill in the first column. This means that I will fill in b plus 4 in the first row. Next, fill in the blue boxes. B times b will give me b squared. B times plus 4 will give plus 4b. Negative 1 times b will give negative b. Negative 1 times plus 4 will give negative 4. How do I write out the working? This is how I can do it. We add up all the four terms in the blue boxes. B squared plus 4b minus b minus 4. And simplifying 4b minus b to 3b, our final result is b squared plus 3b minus 4. Let me now demonstrate using the distributive law. Distribute b to b and then to plus 4 to give b squared plus 4b. These two terms correspond to the two terms here in the multiplication frame. Next, b minus 1 is the same as b plus negative 1. So, we distribute negative 1 to b and then to plus 4 to give minus b minus 4. These two terms correspond to these two in the multiplication frame. And simplifying, we get b squared plus 3b minus 4. Let's look at another example. Expand the product of 2x plus 1 and 3x minus 4 using the multiplication frame method. Pause the video now to do it. Let's go over the working. Where do I fill in 2x plus 1? Here in the first column. And where do I fill in 3x minus 4? Here in the first row. And what are the four terms you get in the blue boxes? Did you get 6x squared and negative 8x and 3x and negative 4? How do I present the working? This is how I can do it. I add up all the four terms in the blue boxes, simplify to get 6x squared minus 5x minus 4. Let's expand the product of 2x plus 1 and 3x minus 4 using the distributive law. Pause the video now to do it. Let's go over the working together. First, distribute 2x to 3x and negative 4 to get 6x squared minus 8x. Then distribute 1 to 3x and negative 4 to get plus 3x minus 4. Simplify, you will get 6x squared minus 5x minus 4. It's now time for practice. Attempt the four questions here. Remember to pause the video as you work on the questions. You may begin now. I trust that you have finished the four practice questions. Let us now check the workings and answers. We shall now take a look at some interesting features in the answers. What is the special name for these four equations? They are called identities. What can you say about the algebraic expression on the left and the algebraic expression on the right of each identity? They are equivalent. Let me draw your attention to the four terms in the blue boxes now. Do you observe anything interesting? Pause the video now to examine the four terms. Do you notice that 1. The quadratic term and the constant term are always diagonally opposite. 2. The two linear terms are in the other diagonal. Well, I believe not many of you have noticed these features. Don't you now find them interesting? Are there any more interesting features among the four terms obtained in the blue boxes in the multiplication frame? Let us now find out. To recap what we have noticed about the four terms in the blue boxes, 1. The quadratic term and the constant term are always diagonally opposite. 2. The two linear terms are found in the other diagonal. Besides these two, there are two more features that I want you to take note of. To help you discover the features, I need you to complete the table. There are four columns in the table. Column 1 shows the product of the two algebraic linear expression and the result. For the remaining three columns, you will need to refer to the four terms in the multiplication frame. Let me show you an example how to fill in this table. Take the product of x plus 2 and x plus 3. We know the expansion gives the result x squared plus 5x plus 6. Here is the multiplication frame. The quadratic term is x squared and the constant term is plus 6. So in column 2, which asks for the product of these two terms, we write x squared times 6 equals to 6x squared. Next, the two linear terms are 3x and 2x. In column 3, which asks for the product of these two terms, we write 3x times 2x equals 6x squared. Column 4 asks for the sum of these two linear terms. We write 3x plus 2x equals to 5x. Now, I'd like you to try the next example. The multiplication frame is given here. Pause the video to work out the terms in column 2, column 3, and column 4. Let's go over the working. Did you get 6x squared times negative 4 equals negative 24x squared in column 2? And negative 8x times 3x equals negative 24x squared in column 3. And in column 4, negative 8x plus 3x equals to negative 5x. Can you now work out example 2 and the 4 questions given under practice time? Pause the video to complete this task. Alright, let's go over the answers. I want you to compare the terms in column 3 with the corresponding terms in column 2. What can you say about the product of the two linear terms? Do you notice that the product of the two linear terms is equal to the product of the quadratic term and the constant term? Now, compare the terms in column 4 with the corresponding quadratic expression in column 1. What can you say about the sum of the two linear terms? Did you notice that the sum of the two linear terms is equal to the linear term in the result, expressed in the form ax squared plus bx plus c? We have almost come to the end of this lesson. Let us now look back and see what you have learned here. Let's recap how to expand a product of two algebraic linear expressions using the multiplication frame method and the distributive law. Consider the product of 2x plus 1 and 3x minus 4. We write 2x plus 1 in the first column and 3x minus 4 in the first row. Then we find the 4 terms in the blue boxes. Add up these 4 terms will give the result. If you use distributive law, distribute 2x to 3x and negative 4. Then distribute 1 to 3x and negative 4. You will get the same 4 terms as in the multiplication frame. Simplify the expression, you will end up with the same result, 6x squared minus 5x minus 4. We have also discovered 4 interesting features about the 4 terms in the multiplication frame. 1. The quadratic term and the constant term are along the same diagonal, that is, they are diagonally opposite. 2. The two linear terms are found in the other diagonal. 3. The product of the two linear terms is equal to the product of the quadratic term and the constant term. 4. The sum of the two linear terms is equal to the linear term in the result. Feature 3 and feature 4 are particularly useful in factorizing quadratic expressions. The lesson has come to an end now. I hope you understand how to perform the expansion of a product of two algebraic linear expressions better. Thank you for watching.